If you've ever tried focusing your telescope at night, you know how frustrating it can be. Stars look sharp, then soft, then sharp again, but never perfect. And when you're doing astrophotography, even the tiniest focus error can ruin an entire night. That's where focusing masks come in. A focusing mask, like the popular Bahtinov Mask, transforms a blurry guess into a precise sign. It creates a unique diffraction pattern on a bright star, and when everything lines up perfectly, you've nailed focus. No more guesswork. But here's the problem. Good masks aren't always cheap, often expensive, or not customized for your telescope. So in this video, I'm going to show you how to design a perfectly sized focusing mask for your telescope using SKI tool, optimize it for maximum focusing accuracy, and finally 3D print it so it fits perfectly. I will also show you various other focusing mask designs, including one I have made, so stay tuned till end of the video. We have generated the focus mask using the SKI tool and exported the SVG file as I want to customize it. STL are very difficult to work with. If you want, you can directly export STL and print it. Let's start our design using the GSO 8-inch adapter. The spider body of GSO telescope is not magnetic, so having this adapter will help, as I will put some magnets on the mask and screw on this adapter. That way we'll be able to snap it on and off quickly. Imported the SVG file of Bahtinov Mask onto our adapter. Let's align the center and adjust the aspect ratio. Remember, this needs to match your design, else you will end up changing the focus mask. It's not super sensitive to minor variations though. Let's draw the outlines as per the file, give dimensional constraint, and we will be ready. I have tried to make all possible focus masks as I can. I wanted to repeat this benchmarking, but with the new design I came up with, which is basically a rearrangement of the slits cut out to generate diffraction. Each of these slots are at 4 mm, and the focal length is 1200 mm, for which this mask is optimized. For reference, a 16 mm wide-angle lens on a camera will have a slot width of 0.5 mm. If you know the focal length of your optics, then you can optimize the mask to maximize the performance of the Bahtinov focusing mask. I have created individual adapter integrated design as well as snap-fit adapter version. All model STL links are in the description. Let's speed up the video. We are ready to extrude. We will give a depth of 5 mm and we are ready. Now this design of tree Bahtinov mask is not compatible for telescope collimation, so I created another tree Bahtinov layout that is very popular amongst astronomers. We will create a collimation mask that will block 2/3 of the pattern, and we will be able to use it for collimating our telescope. Now this is the new design I was talking about. Let's 3D print them on my Bamboo Lab A1 printer using PTG Pro red color. As these focus masks are very thin, the time lapse of the print is not that long, so I clubbed all the time lapses together. I did notice my printer shifting during printing, indicating it does not have adequate grip on the table. This needs to be fixed. Here are all the focus masks I printed. Comment your innovative ways to make focus masks and what you would like me to print next. Let's give you a demo on how this fits onto the telescope. We will first fix the adapter. As you can see, it has screws in it, which will allow the magnets to snap. Every mask has magnets which are 5 mm diameter and 3 mm thick. These are press fit. You can also use a little glue as well to secure it in its groove. See how perfectly it snaps. Easy to remove as well. Here is the Bahtinov mask, named after Russian amateur astronomer Pavel Bahtinov, who invented it in 2005. Perfect. I did a mistake here. I should have created a center hole that would make it easy to remove. I will correct the 3D model. Here is my beloved new design. What do you feel about this design? I wanted to repeat this benchmarking, but with the new design I came up with, which is basically a rearrangement of the slits cut out to generate diffraction. I designed this with an aim to have an equal weighted average slot length for each slot. Very curious to see the result. This tree Bahtinov design allows collimation with the adapter, which is rotated 120 degrees with 2/3 part covered, so each of the 3 collimating screws can be adjusted one by one. This is the collimation adapter. Let's fix it and rotate so the projection on this adapter sits in the circular slot made on the focus mask. These holes are at 120 degrees. Please orient the focus mask with the collimation screws of your reflector telescope, otherwise the results won't be good. Cool. We are ready for the star party. Guys, do like, subscribe and share the video, it really helps. Happy printing.